Okay, this is our experimental setup. So we are having the centrifugal pump. In the light orange color, you can see the centrifugal pump. Above that, they are showing the RPM of that centrifugal pump. Currently, it is not working, so it is showing as a zero. And the centrifugal pump is supplied by the electricity. So on the right side, you can see the electric meter of the centrifugal pump. Again, the number of rotations currently it is showing zero because it is now we are not starting that. And on the bottom, you can see the timer, which can be used for calculating the time taken by the energy meter for completing one revolution or two revolution. So when we are switching on the pump, you can count or calculate those values. And above, you can see the valve positioning. So how to do the experiment? We will be doing the experiment at a different flow rate. How to control the flow rate? We'll be controlling the flow rate by operating the valve in different positions. Okay, so the valve position currently it is zero, completely closed position. And here you can see two gauge, one gauge. Here, this gauge you can see it is connected to the delivery pipe. So definitely this gauge will be giving the delivery head. And this gauge is connected to the suction pipe. So this gauge will be giving the suction head. And the unit also they have given it is kilogram per centimeter square, kilogram per centimeter square. So you can note down the suction head plus delivery head you can note down. And if there is any distance between suction and delivery, you can add that distance also in towards the total head. Okay, you can add that. And here we are having another timer which can be used for calculating the time taken for 10 centimeter rise. On the left side, you can see 10 centimeter rise. We can calculate the time. So this is the values that you have to note down when you are doing the experiment. And you have to note down these value and you have to calculate the discharge. First of all, you are calculating the actual discharge. How to calculate the actual discharge? Area of the tank into height of the water collected. We are collecting for 10 centimeter divided by time. You will be getting the actual discharge. Power input 3.6 10 into n revolution divided into 1.36. K is the energy meter constant and into time for revolutions. Okay, so എത്ര revolution ആണ് നമ്മൾ എടുക്കുന്നത് n കൊടുക്കാം എത്ര ടൈം എടുത്തു അത് ഇവിടെ കൊടുക്കാം and this is the energy meter constant. They have given the energy meter constant as 15.01 and you can directly substitute that. And in this experiment, we are taking for 10 revolution of meter, so n can be substituted as 10. And area of the tank also they have given here 0.25 meter square. And specific weight of water, if you need, you can use that for calculating the power input. Okay. Now power output. Rho GQH, rho G. For that, we are using this value W, and Q, that is the discharge, actual discharge that we are obtaining. H is the total head. So total head will be the sum of the suction head plus delivery head plus if there is any distance between, you can add that also. That is the equations. So here is our tabular column. You are having the pressure gauge reading and vacuum gauge reading. That pressure gauge will be in the delivery pipe and vacuum gauge will be in the suction pipe. So you have to note down these values here. Okay. And you have to calculate the time for 10 centimeter rise of water. Okay. How much time is required for 10 centimeter rise of water? That also you have to calculate. And time for 10 revolution of energy meter disk, that also you have to calculate. Okay. 10 centimeter rise of water, 10 centimeter energy meter disk, you have to calculate that. Okay. So after calculating this value, you have to calculate the speed of the pump if it is needed. But currently we are not using that speed of the pump. We are not. So total head can be calculated by adding the pressure gauge plus vacuum gauge. So here we are not considering the distance between these two. So we are not adding that. And the flow rate you can calculate Q is equal to A into H divided by T. You can substitute that values here. Input power, again, you have to calculate using the equation. Sorry, input is this equation. You have to write down this value, output power, and you'll be getting the efficiency. Okay, so this is the tabular column that you are supposed to complete. You can fill the values and you can complete this tabular column and you have to write that into the final record. Okay, so let's see how we are going to do the experiment. First of all, we have to turn on the machine. So I am clicking on the power on button. Now the reciprocating pump is working. It's RPM, you can note down. Okay, this is the RPM. And currently we are keeping the valve in zero position. So no discharge is there. So you cannot calculate the time for 10 centimeter rise. Okay, so we have to open the valve. So how to change the valve position? I will be changing from 0 to 1 here. Now the valve is open. Now the liquid is flowing. Okay, now the liquid is flowing. Now you have to calculate the time for 10 centimeter rise. How to calculate the time for 10 centimeter rise? Here we are having a gate valve. Okay, so I am closing that gate valve. So by clicking here, I will be closing that gate valve. When I am closing that, it will start rising on the left side. From that, you can calculate the time for 10 centimeter rise. Okay, so now I'm closing that and you can see the time for 10 centimeter rise. You can note down this time. This is the time for 10 centimeter rise. Now you have calculated the time for 10 centimeter rise also. Now we have to calculate how much time is taking for energy meter revolution to calculate the input power of this device. So click on the energy meter icon. Now they will be counting the time for 10 revolution of the energy meter disk. Now you will be getting the time as 50 seconds. You have to note down. So what are the things we are noting down? We are noting down the RPM. We are noting down the wall position. We are noting down the time for 10 centimeter rise. We are noting down the time for 10 revolution of energy meter disk. And you can also note down the time pressure gauge reading and the vacuum gauge reading. You can note down the pressure gauge reading and the vacuum gauge reading. Okay. Now you can change the valve position from 1 to 2. Okay. Again, we are adding the valve position from 1 to 2. Okay. Now we are closing the same procedure will be obtained, closing the gate valve, and we are calculating the time. Okay, this is the time. And we are taking the energy meter reading. This is the energy meter, 10 revolution of energy meter. And again, we are noting down the suction pressure and the gauge pressure. Now it is vacuum pressure is increased. Okay, so you can note down the vacuum pressure and you can note down the gauge pressure. So both we have noted down. Okay, so again, we are changing the valve position into 3. Now at a different flow rate. Again, we are repeating the same procedure. We are calculating the level of water collected and we are calculating the energy meter reading and we are noting down the delivery pressure remains same but suction pressure it is increased. Okay, in our previous experiment when we are doing the suction pressure we are substituting in terms of millimeters of Hg, but here both values are substituted in terms of kilogram per centimeter square. Okay, so now we are going to the next position, fourth position, same procedure, closing the gate valve, next step, and calculating the energy meter value, next step. And last one, the fifth gate position. Again, we are going to fifth gate position and closing the valve. Okay, closing the valve, and again we are taking the energy meter reading. So this is the step-by-step activities that you have to do for calculating all these things. Okay, so we
സാർ
have, yes,
സാർ ഹംനയ്ക്ക് കയറാൻ പറ്റുന്നില്ല എന്ന് പറയുന്നുണ്ട്. 12:15 മുതൽ നോക്കുന്നുണ്ടെന്ന് പറഞ്ഞു.
okay, so I will try. Okay,
ഓക്കെ. താങ്ക് യു സാർ.
so we have completed 5 sets of reading. Okay, we have completed the 5 sets of reading. So you have to note down all those values in the table and you have to do the calculations. Okay, so after completing the calculation, you can copy these values to your notebook and you have to write down the aim principle, what you are supposed to write as aim principle that I will share. But for the time being, you can do the calculation by yourself. I will share this link. I will share this link in the chat box so you can do the calculations. Okay.